So, first of all, I would like to welcome you all for day 3 session on authentic engineering at your fingertips. Last 2 days, we had various sessions on basically initially on parametric modeling, engineering drawing fundamental, and later we also saw about the solver sketching, how the parametric sketches to be created and various other things. Today we are going to focus on the core fundamental of engineering. Okay, and engineering starts with the terms called it as a gear. Okay, and I would like to throw a more light on gear selection, types of gear. Okay, we have a certain problems. Okay, these are the industrial problems, and based on the industrial problems, how to select the gear from the available catalog is the important task. And to select the gear from the catalog, we also require many things, many calculation things initially we have to prepare. So I would also like to give you the entire things about this. I know that this session is we usually take at for inside our office for almost 3 to 4 days, but I will try to cover up as many as point along with the design calculation. I have also designed few Excel sheets from which you can directly enter the few inputs, and you can be able to get the output in terms of the gear selection. Okay, so let's begin with this. Give me a second so that I will close my browser, and so that we'll not going to hear any disturbance on WhatsApp and other things. Yeah. So coming back again, so let's begin with the gear design and calculation. But before start of the gear, first and foremost thing we need to consider is what are the types of gear and what the purpose we use a gear. Okay, because to understand the purpose, because we know that as a mechanical engineer we want our machine to run. Okay, to run the machine we use an engine, we use a motor called it as a primer along with the gearbox, so that power is transmitted from the input, that is from a motor, okay, to the other shaft. Okay, there are few things we need to consider in between this. Let's have a few things about this. Just a reminder to everyone. Okay, reminder, this is the most important session for everyone, and these three your soulmate are already here. Many interview questions are aligned with today's session. It means almost every interview, I called it as almost 100% interview, you will get it the one or two, three questions related with this topic, and 100% I have covered all the questions which is asked by the any designer during the interview. Okay, that is the I'm sure about it. Okay, so I use for a gear and majority of the calculation of the broach and all for almost 2 3 years for one of the reputed companies. So any details you want, even for a profile calculation, even an involute calculation based on the XY coordinates. Okay, we have a sufficient information about it. The only time is the constraint, but definitely I would like to cover it as much as can. So agenda, first of all, I would like to share you about the drive system, because at many times we are in a confusion whether to use a belt, okay, whether to use a chain, whether to use a gear, whether to use a coupling. Okay, because these all are used to transmit the power from one shaft, or we call it as an input shaft, or we call it as a driving shaft to the driven shaft. Okay, so first we'll see about the drive system. Then very quickly, I would like to explain you about 2 3 important gears. their types very quickly, and the terms I will skip it out because I don't want to go. This is already available in any of the machine design book. But just for the sake of understanding, I have highlighted few formulas, maximum 3, 4. Okay. But the terminology and other things are huge. I will not spend too much time on this because this is the all things are available on book. My major concentration on selection criteria for gears. Okay, and based on the we have certain selection criteria, so we will take it one problem. That is, for example, we have a certain machine with us. Okay, we want some volume to be taken care. We have some power, and based on that, we need to select the gear from the available catalog. As a machine designer, I will not going to design my gear for as per my application. Okay, I will first ensure that I will select the gear from the available alternatives from the other catalog. Okay, because my core purpose is to design the machine, design the robot, design the SPM, design the mode. My core purpose is not to design a gear. There are a lot of vendors are already there who are specialized into the gear. Okay, so my first as a machine designer, I must be specialized into a picking up the right gear, okay, as per my choice. Okay, so that is the things I would like to explain with the industrial few industrial application, and definitely your soulmate are with you, so which highlighted with the interview questions and all those things. In between, if you find any terms is difficult, you can add your question. Okay, and I would like to happy to answer your question along with it at the end of the session. So, drive system, excellent things. I have tried to add many graphical animation for this. You can see it's have a belt, okay, two shafts. We have a chain which is with the sprocket. It's highly innovative idea. We have a flange coupling, okay, and third image, okay, where we can transmit the power from one shaft to the other shaft, and lastly we have a gear. Okay, so I tried to cover up a few things which is going to be uh, which is going to be included inside the drive system. So if you concentrate more focus on it, okay, coupling is used when your shafts are aligned. Okay, your shaft axis. Okay, whenever I'm talking about shaft, okay, ensure I'm talking about the axis of the shaft, and axis of the shaft is always lies with length of the shaft. Okay, ensure, because these terms I will use, I mean it means I'm talking about shaft means length of the shaft, and over the length of the shaft we will get the axis. Okay, once we see from a front we will get the doctor plus and circle. Ignore that one. I'm not talking about that doctor plus axis, okay, which is called it as the center mark. I'm not talking about the center mark. Whenever I talk about the shaft, it means along the length of the axis. Okay, along the length, and that axis, okay, whatever the length covered, okay, that I'm talking. And if you concentrate this thing, okay, if you know the axis, next, this is only my first requirement for you people. If you know what axis is your, you are much better position to get the all the things related with this. So here for belt kind of a thing, we have a two shafts, okay, two shafts which are parallel to each other, okay, but there should be a certain medium is used. Okay, in chain also we have a two sprocket, but there is a certain medium is used to transfer the torque from one shaft to the other shaft. In belt, we use a belt as a medium to transfer the torque from one pulley to the other pulley. In chain, we use a chain to transfer the torque from one sprocket to the other sprocket. Okay. In coupling, we have a flange. Okay, there are lots of coupling. Okay, here I have taken the coupling which is having a axis is coaxial. There might be a certain misalignment at that time. We have a Oldham coupling, universal coupling. Okay, these are the applications are different, but you understand the axis of the shaft for this particular example is collinear. And then we have a very handsome gear here with blue, and in between that we have added a red color idler gear. So here the engagement, there is no medium, understand? There is no medium when the but the shaft is parallel. Okay, shaft axis is parallel. Whatever the gear A we have a gear B, we have gear C. All three axes are parallel to each other. Okay, understand? All three axes. When this is I'm seeing from a front, so I'm getting a doctor plus or center mark. But when I'm seeing from a top for that gear, whatever the shaft length I'm getting, that both the shaft, okay, both the shaft axes are parallel to each other. But here the torque is transmitted. Okay, we are not using any kind of a medium like a belt, like a chain, like a flange cuff. Okay, we are not using any medium. Whatever power is transmitted, whatever torque is transmitted, is due to successive engagement of the tooth. Okay, is due to successive engagement of the teeth, and you need to first understand this thing. Let's begin with the next thing, because this is very important. Because if you know you have a long distance, okay, you have a sufficiently long distance, and it is impossible to design the drive gear and driven gear, okay, and we do not have a space accordingly. So we have to use either a belt or either a chain for that drive. For example, conveyor. Okay, we have a belt conveyor, we have a chain conveyor. We know that conveyor is in length. Okay, we have 1 meter, 2 meter, so we can't generate the 1 meter or 2 meter gear for a successive engagement of the teeth. Understand, that is the most important. In gear there is no medium is associated with it. Let's move for our next slide. So I have told you about now fundamentally towards gear. Gear is basically a wheel. Okay, it's a tooth wheel which transfer the torque. Okay, with certain speed variation from one shaft. Okay, one input shaft. Okay, from driving shaft. All are the names same. Input shaft, driving shaft. Okay, or one shaft to the other shaft. The other shaft is driven shaft. Okay, other shaft is a driven shaft, and whatever the engagement is happen, whatever how we transmit the motion between this is because of the successive engagement of the teeth. Okay, it is due to successive engagement of the teeth. Understand, there are two things, okay, which is I think almost many books this is not written. For external gear, okay, for external gear, when two gears are successively meshed with each other, okay, when we have an external gear, external type of gear, which is you can see the image of it, external type of gear, when axes are parallel, if one gear rotates in clockwise gear, next successive gear is rotated into opposite direction. It's called as anti-clockwise direction. If second rotate in anti-clockwise direction, next successive gear, third will rotate into the clockwise direction in case of external gear. In case of external gear, the successive engagement of the next gear will have a change of direction. Understand? Will have a change of direction. But in case of internal gear, okay, in case of internal gear, if, or we call it as a planetary gear, if input shaft is rotated in a clockwise direction, in case of internal gear, input shaft is rotated in a clockwise direction, the driving shaft or output shaft is also be rotated in a clockwise direction. Okay, but this case is reverse for external gear. That needs to be remembered all the time. I find lot of failure because of this. Okay, people a very small theory. Okay, very small theory in an external gear, we get the opposite direction. In an internal gear, we get the same direction. But many times during the selection of internal gear, we find out the difficulties, and it was heavier at that time, because it is a major loss of time, delay, cost, everything has been happened. One thing I have missed for the coupling. Now, if you see these four images, all where it means for a belt, for a chain, for a gear, we get the reduction ratio, speed ratio, velocity ratio, whatever you call it as. Okay, we get it either the speed, you call it as a speed ratio or velocity ratio, or you call it as a reduction ratio, anything, all these terms are same. But in case of coupling, coupling is a basically a positive engagement where, okay, where whatever the speed of the input shaft, you will get the similar speed at the output shaft, excluding the losses, excluding the frictional losses. Okay, anyway, there should be a certain friction losses in between that, but for coupling, you will not get any kind of an ratio, the speed reduction or speed increase. Okay, you will not get it. But for a belt, because belt is responsible for, you have a pulley accordingly. Okay, variation in diameter of the pulley, you will get the speed variation. Same thing happen for a chain sprocket. Same thing happen for a gear. So that is the point I was missing to it. That's I have covered it here. So next part of it is the type of the gear. Okay, I will only explain the first three. Okay, ensure that we have three important types, and this question is almost on majority of the government exam. Okay, and selecting what is bevel means, what is intersecting, what is non-intersecting, how these are differed with each other. Okay, understand whenever we have a shaft axis is parallel to each other. Okay, whatever the example we saw in our earlier slide, it means shaft axis means parallel to each other. We use a spur or helical. Whenever we have a shaft axis parallel to each other, okay, and they are coplanar, they are on the same plane. Okay, parallel to the, okay, their axis is parallel and they are on the same plane, we use a spur gear or a helical gear. Okay, then the second case, when the two axes are at 90 degree, two axes meet somewhere at 90 degree, that is called it as intersecting. It means axis becomes interfere. That physical gear, yes it is, but somewhere their axis has to intersect. Okay, and the last one, and the bevel gear family, all the bevel gear, miter gear family comes into the intersecting shaft. And the last one is the shaft are not parallel with each other, non intersecting each other. Means what? If you see from a top plane, you will get it, sometime you will get it one shaft and one circle. If you see from a right side, you will get it one circle and one shaft. It means they are not neither parallel nor uh, they are not intersecting, not even parallel. Let us just give me a 2 minute. There is some disturbance here. Yeah. Thank you. Yeah, there was some disturbance. So there was some voice set outside. So I thought that I will take pause. Okay. So let's elaborate. I have elaborated this with a very handsome schematic sketch. Okay. I will start with my new slide. Here you can see this. Okay, we have a two color. Okay, I have mentioned the shaft axis. Okay, axis of shaft is parallel. Yeah, during the spur gear, the axis of the shaft, both the shafts are parallel. Okay, so this is the case where we have to use, okay, this is the case where we have to use the spur or helical gear. You understand, whenever I'm talking about shaft, it means it is the axis of the shaft. Okay, understood? So this is this case for parallel axis. Okay, this is this case of parallel axis. Next one. Okay, I have drawn. Okay, here we have a two shafts. The second view I have drawn it. Okay, either you see from a bottom or you see from a right. I have mentioned the direction also. Here, this shaft axis. Okay, if I extend it after some time, it will going to get intersect here. This shaft axis after some time will going to get intersect with each other, and the angle between these two shafts is 90 degree. Okay, or any degree. Now bevel gear is also be you can get it in a various angle, but assume that two axes of the shaft are intersecting. That's they are intersecting, but they are not parallel, because parallel means angle is zero. Parallel means the angle is zero, but here they are intersecting with each other, and two axes are having an angle of 90 degree. That's why it is called it as non-parallel but intersecting of axes. Okay, and this is comes in a family of bevel gear. Okay, we have a next type of gear, handsome gear, where we have neither intersecting non-parallel. It means एक जातो नॉर्थला, एक जातो वेस्टला. Just I'm giving you an example. It means you see this, a bottom is we have a worm, okay, which is a looks like a shaft, okay, and the disc, okay, which is tooth disc. It's called it as a worm wheel, okay. In a blue, I have mentioned it, okay, okay. They are not neither parallel. Their axis, it means their axis means what? Their axis not for this Doctor Plus. This is whatever the view. I am misciting that view. Just a second. Yeah, I have it here. Okay. So these two axes never do not have any relation of neither parallel nor intersecting. I'm talking about the shaft. Okay. So that is the called it as, this is the category where you can go for a worm kind of an gear. And we have discussed about the what is the types of gear. Once you know that what means parallel, what means intersecting, what means non-intersecting, okay, then you comes into the mind whether I have a sufficient distance. Okay, I have a distance where I can use a gear or gear train or with the help of some idler gear so that I can accommodate the sufficient length, or if the length is larger we have to go for the next type, which is either belt or chain, depend upon the application. Okay, let's see about the next point. This we discuss, okay, parallel axis. I don't want to go in a detail of it. Non-parallel, non-intersecting, okay, all other things. The rack and pinion is one of the important one, okay, and which is to be used in various type of application. Okay, so that also we need to ensure. You just quick round on a spur gear. We understand that gear axle, the shaft of this gear must be parallel. They must be on a coplanar. So only one thing is ensure that whenever spur gear or successive spur gear are engaged, okay, they have a face-to-face contact. Okay, they have a face-to-face contact, and one tooth will engage at one time. It means it will engage the first tooth, okay, then once the first tooth comes out it will engage the second tooth. Okay, so at a time engagement with only one tooth. Okay, at a time whenever you transfer the torque from driving shaft to the driven shaft, engagement happen with only one tip. Okay, and that creates some excessive stress and noise, and we have a connection as a face-to-face contact, surface to surface contact. That's why it creates the stress also, and only one tip are going to be in engagement, so this also create the high stress. Okay, so and these are the involute profile. There are a lot of profiles are available. Apart from this, for a spur gear, okay, for a spur gear there is no any axial force. Okay, axial means along the shaft you will not have any kind of an force. You can see this axial axial force means this shaft. Okay, I have this the shaft which is on a pinion, which is a small gear. Okay, there is no any kind of an force added on with the help of a spur gear. Okay, because gear are extremely, they are cut parallel. Okay, parallel, no angle between the tooth. Okay, so that it's a very handsome case. These are very used for the lighter application. Okay, and you can get the engagement of the tooth, but the major disadvantage of this gear is its cause and noise. Okay, and high stress. Okay, and surface to surface contacts. Okay, surface to surface contact in between the two successive teeth. Next part of this is related with the helical gear. When we have a shaft is parallel, but we have tooth are a little bit at an angle. Okay, called it as the shape of helix. Okay, and the engagement. Okay, I have told you in spur gear engagement happen with surface to surface and one tooth at a time. But in helical gear, because of that tooth are cut at an angle along the axis. Understand, profile remains same, but tooth are cut along the axis. Okay, that whatever the tooth are cut, it's at an angle with the axis. Okay, with the in angle with the axis of the shaft. So one, the teeth are engaging gradually. Okay, teeth are engaging gradually. At a time, multiple teeth are always be in a mesh. At a time, multiple teeth are always be in a mesh, and okay, this have a point contact. Earlier in helical here, we have a face-to-face contact and one teeth engagement at one time. But here, inclination is along the axis, okay, so that inclination is along the axis, so multiple teeth are going to engage at a time, and due to the multiple teeth and inclination, the point contact is there. So this is basically having a very less noise. Okay, noise is very less because less vibration creates, and it can be used for medium to high speed contact. Okay, but due to the engagement is happened over the axis. Understand? Engagement is happened due to the axis also. Shaft axis are coming into the picture. Okay, so it causes an axial force also. It causes an axial force also along with radial axial force, and we know that whenever we have a axial force, we need to design a bearing. Okay, we need to have a design of plumber block which supports the shaft to ensure that whatever the axial stress, okay, whatever the axial force, it is to be get absorbed during the bearing. Okay, so for helical gear, for location of the shaft, you also require to design a bearing accordingly. Okay, for that specific load and all of the categories. Okay, but spur gear, okay, no need of an designing the heavy kind of an roller bearing. But here, due to the axial force occurs, okay, due to successive engagement and multiple ticks are there, you require this creates an axial force, and a significant role of bearing selection comes into the picture when we use a helical gear. Another part we have it is bevel gear, where axes are 90 degree with each other. I have told you somewhere in the axis. Okay, if I in the first straight, okay, you can take the example of here. Okay, the first axis of the shaft, and we call it. Okay, you can imagine we call this as a horizontal gear one. This is vertical gear. Anyway, this axis will meet at certain point. Okay, when we extend the axis. So that kind of things where it is to be used for as called it as a bevel gear. This also be a very important when we require a transfer of the power at 90 degree, because if you consider we have a belt, we have a chain, we have a sometime we'll have some coupling switch and give the inclination of the power transfer. But 90-degree power transmission, if we have a requirement, then this is going to be the perfect criteria where you can usually select the bevel gear box for the same. Okay, so and the spiral bevel gear, the shaft are perpendicular to each other. It will be a very balanced one. Okay, which have a point-to-point contact. Okay, here in straight bevel gear, they again a face-to-face contacts creates one engagement of the tooth at a time. Okay, because why one engagement happen? Because unless and until that first teeth will not come from the successive engagement, the second teeth will not get engaged. Okay, so that is the reason. For a straight kind of an cut, we have a challenge. But for inclined cut, the inclination is always given. Okay, so due to the inclination of that, it will be able to engage the multiple teeth at multiple times. Same logic is also applicable here, or straight or spiral kind of thing. And for hypoid is a little bit in a family of worm. It looks like the same kind of thing, but let's not depend. This is very important. That's why I marked this in your soulmate here. Worm gear again very highly used in industry where you require a high amount of reduction ratio. I repeat, worm gear is used to get the high amount of reduction ratio itself. You will not get any kind of an positive ratio. It must be reduction ratio. Okay, and second thing, you imagine the worm gear. Okay, the worm rotate. Okay, worm is connected to the motor. Worm is connected to the we can call it as a prime mover engine. Anywhere, it means always your driving member is worm. Due to worm rotate, okay, worm rotate at certain speed, and we want a high amount of reduction in torque. So worm rotate the worm wheel, and worm wheel have a higher diameter. Okay, understand the things. It never happen that your worm will rotate. Okay, it will never happen that your worm will shaft will have a driving. Okay, it never happen, because what happen, Worm will have an inside arrangement, like a arrangement is something such like that. If you try to rotate the worm, rotate the looks like a shaft, rotate the worm, okay, it will easily rotate the worm wheel. Okay, it will easily rotate the worm wheel, but in opposite way, vice versa is not possible because of the lock or engagement. Okay, vice versa is not possible. You cannot turn the worm. Okay, you cannot turn the worm so that worm is you cannot turn the worm wheel. Okay, you cannot turn the worm wheel and worm wheel, the vice versa of the things is not possible due to the locking mechanism associated with the worm wheel. That is the only one point I would like to mention. Another point is number of turns on a worm. Okay, how much amount of torque or how much amount of reduction ratio you receive is also be depend upon the how much what is the turns over a verb. So that is the one concept is added into it. Okay, but we don't want to go in a detail of it. There is enough things are already available on a book. For us, we know that we have one PCD, which is all gear selection has been done based on a PCD. One thing is clear to you. Okay, all things. Okay, we imagine that PCD pitch circle is basically imaginary diameter, okay, which is going to be used as a for a specification of any gear. Okay, upper diameter is called it as a addendum diameter, lower diameter is called a dedundum. There is some root diameter below that. Thickness, that whatever the thickness of the tooth is called it as a tooth thickness. Okay, whatever the gap thickness is called it as a tooth space or something. So you can go with this. Okay, I don't want to spend too much of a time, but the important one is I have talked about the PCD. Okay, we call it as a major dia, minor dia. Okay, because these are the requirement for design calculation. Okay, there are few formulas are also be associated with it. I have mentioned the pitch circle is one. Okay, I don't want to go into the pressure angle, how the connectivity has been happened, what are the different pressure angles are available. So I don't want to go into this. These are already available on many books. Okay, so you can try it out. This is the important one, pitch, circular pitch. Okay, so whenever a circular pitch is basically a distance between the first tooth, okay, first tooth where uh, it meets to the PCR, it meets to the pitch circle to the next tooth. Okay, so that is the distance between these two. It's called it as a circular pitch, and this is basically very important one. And this already it's always calculate. We have a circumference 2 pi r divided by number of teeth. You will get it the distance between that. It means first start to the second start. Whatever the distance between the first start point to the second start point is absolutely circumference divided by number of teeth. You will get it the circular pitch. And this is the where mostly many interviews this question is compulsory because very simple. First start to the next start distance, but we know that the circumference of the circle is 2 pi r or here pi d. Okay, divided by number of teeth, we will get the circular pitch of it. This is formula is extremely important. We have a module m is equal to d by t. I will give you one tip to you. Maybe in my calculation we will get it. If the successive engagement for any successive engagement of the gear, I repeat, any successive engagement of the gear, your module must have to be same. Okay, if I have a suppose I have a 12 teeth. Okay, I have a 12 teeth gear. One, I have a 24 teeth gear. Okay, we have a one gear as a 12 teeth, another gear as a 24 teeth, but we always require a module of the both the gears are same. Okay, module means what? It's a diameter divided by number of tooth. Okay, so m is equal to d by t. So, and this is also be a math calculated mathematically. You cannot measure it anywhere. But for example, I have a one gear whose PCD is suppose 48. Okay, so 48 divided by 12. Okay, so we get the 4 as a module. Okay, for one gear we have a 48 as a 48 mm as a PCD. Okay, divided by 12, we have a we called it as a we have a m is equal to 4. So who will be the second e gear which engage with this module 4? Okay, It means suppose we have another gear which have a which we have 24 as a number of teeth. Okay, so for number of teeth we have a 24. It means 24 into 4 we require 96 as the PCD of other gear. Okay, so that 48 divided by 12, we are getting 4 as a module. 96 divided by 4, we are getting again a 4 as a module. If the module remains same, then and then only, if the module remains same, then and then only the successive engagement of tooth will happen. And this is extremely important criteria for design of the gear. Okay, your pitch circle diameter variation, it's okay, no problem. Your pitch circle dimension variation, no problem. Your number of teeth, no problem, it may vary, but whatever the calculation comes, their module must be same. Here we have a 48 divided by 12, module is 4. Okay, or 98 96 divided by 4, 96 divided by 24, again we are getting the module as a 4. So this 4 number d by t ratio is most important, and only torque will get transfer if the module is same. Okay, that is the design criteria I would like to highlight to you people. These are already available into it. Backlash is I would like to highlight because this plays a very important role. Backslash, it means it's a certain gap between the two spaces. Okay, two toothpastes, it means one toothpaste will engage with the another gear tooth. Okay, so that whatever the gap is going to get created along the PCD, that is called it as a backlash, and this have a certain calculations and all other things. Will not go into detail of it. The most important term is gear ratio. Understand? And this I would like to highlight very frequently. Don't forget about this. What is the gear ratio formula? It means number of driven gear divided by driver and all other things. I will explain you in a much better way. The gear ratio, velocity ratio are the same. Okay, it means sometime it called it, and this is applicable for sprocket, same. This is applicable for pulley, same. Whatever the belt you calculate reduction ratio, all there you have a similar kind of a gear ratio, which gives you the reduction, okay, or increase of the speed of the shaft. Okay, which gives the reduction or increase of the speed of the shaft. Let us elaborate little bit more for this in different terms. Okay, I will highlight you with this. So always we have a one driving shaft. I will explain you because the formula and all those things we need to evaluate very efficiently. So we have a driving, okay, we have a driven. Okay, we have a one thing is driving, we have a one thing is driven. So velocity ratio remains same. So v is equal to pi dn by 60. Okay, I have written it pi. Okay, pi dn by 60. For driven, we also have a pi dn by 60. For driving, I have called this as a pi. D1 n1 is for my driving. Okay, and D2 n2 is for my driven. Okay, it means my driving is a motor or prime mover or engine, and my driven is, okay, is a compressor. Imagine, okay, this is the, we want to calculate the formula for the same. So we know that pi 60 60 got, it's a mathematics, pi on both the side we cross it. Okay, then 60 60 also we get okay, we can omit that one, okay, because it is same on right and left hand side. So remaining is n1 d1 or d1 n1 equal to n2 d2. Okay, n1 and d1 are responsible for driving one, n2 and d2 are responsible for a driven one. And then we have a ratio, n1 by n2 is equal to d2 by d1. It means speed have a inverse relationship with the diameter, which is a pitch circle diameter. A speed have a inverse relationship with the pitch circle diameter. Either you can take it n1 by n2 equal to d2 by d1, or you can take it d1 by d2 equal to n2 by n1. Both the way, the only important thing is you take it any driving top or driven top. The important thing is the speed and diameter must have a inverse relationship. Okay, that is the most important thing in speed ratio, applicable for belt same, sprocket same, even a gear also be the same. So let's have a very small problem with us. we have a 100 teeth gear, okay, 100 tooth gear drives a 25 tooth gear. Okay, so calculate the gear ratio. So we have a 100 tooth gear, okay, so which is going to be the driver one because it drives the 25th gear. So we are getting a speed increase, okay, because 100 tooth means we require a higher amount of diameter, and for 25 foot we have a less PCD, so definitely we'll get the increase of speed up to 4. Okay, so very basic basic calculation, but you need to ensure that whether you are getting an increase of speed. Okay, ensure that whenever your input shaft diameter, I repeat, whenever your input shaft diameter is larger than your output shaft or driven shaft, you will get a reduction in speed. Whenever you have a input shaft as a larger and output shaft as a smaller, you will get increase in the speed. Okay, okay, it's depend upon where is your motor. It is where is your engine, where is your prime mover. If the diameter of the prime mover is larger, PCD of this prime mover or engine is larger, we get the increase in the speed. If PCD of the prime mover or engine is less, we will get the reduction ratio. This you need to fundamentally understood. If you understood this, definitely you will get it very handsome thing fun. The next is very interesting one is we have a gear one, okay, having going with the speed of S1 and teeth with the T1, and we have another gear which is having, we call it as a driven gear, which again have a S2 speed and T2 speed teeth. Always remember and speed and teeth, okay, speed, okay, and tooth, whatever the tooth, they are, okay, they are directly proportional. Okay, they are directly proportional. So we have a relation S1 into S2, S1 into T1 is equal to S2 into T2, and whatever the formula you will get it. Okay, you can just check it out this, and you will get it the variation from it. So a very handsome problem is there. Okay, so 28th, okay, running the we have a S1, okay, we have a T1 as a 20th, we have a T2 as a 10, okay, and we get the revolution 100 revolution for a motor. Okay, so definitely my driven teeth are less, so PCD is less, I must have to get the higher amount of torque at the output shaft. So very simple. If you remember the driven is equal to drive, that will be the best way. Okay, in terms of in terms of initially I have told you about N1 and pi D1, okay, divided by 60. This is the combination of velocity ratio, and then second I have told you about the directly proportional ratio. So these both of the any of either of this one problem is 100% of your in your interview, and this is really important for you people. Okay, let's quickly move forward because lot of things are till there. Now it's a selection of gear. We know that how to we know the basic fundamentals of gear. Now I want to select the gear for my application. I repeat, this does not include any kind of an strength, stress, or deformation calculation. Just give a minute. I want to drink of water. So this is basically a second and most important topic we'll like to discuss: selection of gear. So selection of gear, whatever I'm discussing right now, this not include any kind of an strength, stress, deformation calculation. But because many times in my career also, it was hardly happens. Okay, or twice I have did the stress or strength calculation. But during my career, I have selected young number of times, almost 200 300 times the selection from the catalog. So the most important thing is how you will select the gear train from the available internet alternatives. Because once you select the gear from the catalog, now it's that vendor's responsibility to ensure that you will get the correct kind of an gear for, or whatever the selection is, it should be withstand with the application, whatever the stress we have, it, the formation we have, strength we have. Let's see. For a design gear, now we have a one problem with us. Okay, select the type of gear to use for a volume of around it's 0.047 meter cube second. Okay, this is we have a reciprocating air compressor which is going to be drive for a 50. I think it's a 50 HP. We have a motor. Okay, and 50 HP, if you calculate the ratio, you will get it 37.3 kilowatt. Then we require compressor and shafts. Okay, both these shafts are parallel to each other. Okay, it means this gives the indication. Now the problem, okay, whatever the reduction I wanted, the shaft is parallel. So either I have a choice to use the spur gear, or either I have a choice to use the helical gear for that. So all the other families of bevel, worm will going to get discarded automatically. Okay, so let motor shaft turns at a RPM of 1800, while the compressor shaft turns at the RPM of 300 RPM. Okay, and now calculate the distance and select the gear from the catalog. Okay, calculate the distance between the shaft. We don't have any distance they have given. Only I know this kind of a problem that we have 100 ft cube per meter cube per second. Okay, and then we required drive driven, the air compressor is driven by 50 HP, 50 HP electric motor. Okay, compressor and the motor shafts both are parallel to each other, and they have a 53.3 centimeter distance between them. So let's see how, what are the steps which are going to get included into this. So first and foremost things uh, we have to think about is basically the type of gear I have to select. Okay, first and foremost thing is type of gear we have to select. Then we need to calculate the center distance. Okay, then we need to, if it is the center distance is okay, I have decided to go with the gear. I know that I am designing for a small distance between the two parallel coplanar shaft. Okay, then we need to calculate the gear ratio. Once we get the gear ratio, we need to calculate the PCD of the gear. Once we know the gear ratio, once we know this PCD, we can automatically get the number of teeth. Once we get the number of teeth, definitely we have a PCD, we have a number of teeth, we can check it directly a catalog, where on all the catalogs you will get the information about the PCD. Okay, you can pick the PCD. If you know the PCD and number of teeth, you can able to select the gear as per your requirement. So these are the few steps which we required to get it for selection of any gear from the catalog. Let's quickly talk about this. Okay, we have a, these are the steps we want to get. Type of gear, they have directly mentioned it. Okay, that parallel shaft. So we have a choice. Okay, either we can go for a spur or helical. Okay, external or internal. We know that external gear, they change the direction. Successive gear will change the direction. Most of the time, okay, whenever you have a space, available space, so go with the external gear, because it is very easy to design. Okay, it is a very easy to for a maintenance purpose also. And whenever you have a space limitation is less, okay, for a planetary type where you want to engage everything on inside a planetary box, okay, inside a main gear itself. Okay, so at that time you have a choice for internal gear, but as far as possible, a mechanical system have a space, so you definitely go for external type of gear. So for this application, okay, I want to go with a spur gear, okay, because this will be we want to use this for the application. So let us see. I have decided this. So this is the available catalog. Okay, you can get it, this information from CMTI, or this book is very old book of Magrat. This is Mr. Darley W. Okay, which is used for gear selection. It's 1954. Okay, and registered books. They have given certain tables. Okay, they have given certain tables that whenever you have a spur and external gear, or spur and internal gear, or helical and external, or helical and internal, and axes are parallel, you go with this type of gear. If axes are intersecting, you go with this below 4. If not parallel, not intersecting, you have a other type of gear. So we have selected a spur with external type of gear. So table 14 work is done. Then whether we have to select the spur or helical, how to select, this again depend upon the how much HP you are going to transfer. Okay, what is your application is. So here there are some catalog values are given. So whether it is a high power, it means up to 15000, it is 15,000 HP. Okay, for a medium compact, okay, all those things are application are here. This is again a table is given. No one will mug up this table. I will repeat, this table is already available with all the design data book, all the selection criteria of the book, or the person who manufactures the gear. Okay, the company who manufactures the gear, they have their own catalog. They will decide that up to this HP you can go with this, up to this HP. They all the information are given. The only one thing is you must have to be in understanding with how to read the catalog. And unfortunately in our curriculum, okay, we never read any single catalog during the entire things. Okay, this is the most important, that here I need to, you must have to be capable to read the CMTI. Okay, CMTI or design data book. Okay, then based on that we have selected the third criteria, whether I want a very precise gear, or it is required little bit loss of power friction. So depend upon the third criteria, we need to select if it is a precision, means which gear you want to use, then what kind of a branch it is, whether you have to go with the involute profile, or you have to go with EP cyclic, or you have to go with serration, or you have to go with interspace. So there are a lot of things are included into it, but I'm more comfortable with a simple gear or helical gear, which is going to be used by 80% of the application for parallel gear thing. Then there is another terms we need to think about the cost. Okay, whether gear cost, simplicity, whether it is to be easy for maintain, easy for use, and all that, all those things. Okay, if you are familiar with the table and you have selected 2-3 gears from the available resources or available catalog, definitely once you are ready, it will be clear to you. Okay, we know that whatever the toys, okay, kids are playing with the toys, instrument, industrial, all those things are made up with the Spur Gear. So, because it is very easy to manufacture, and they don't know, they are not worried about how much is the power loss. Only our child has to be happy. Okay, that is the this is depend upon the purpose and investment and the cost of the product. Okay, so they don't want to give the worm for a small application or toys application. So else the cost will be increased a lot. Okay, so once I have selected this one, now I need to compute the center distance. So we know that in problem we are given the distance between the two axes is 21. Okay, it means that whatever the PCD I will use, okay, of driving gear or driven gear, if I have a driving gear PCD radius, I called it as R1, and driven gear I called it as R2. Okay, so here I have called it as RD1 is the radius of my driving gear, RD2 is the radius of my driven gear. So distance between these two is 21. I'm seeing that both PCD are in tangent with each other. Okay, something like that. We will get it. Okay, so RD1 plus RD2, because we know that two shafts are parallel to each other, two shafts are coplanar. Okay, so one radius of driving plus other radius of driven equal to 53.3 centimeter, or you can take it a 21 inch. So this is my equation one, because this is already knows. Okay, already I have created a machine with this kind of an arrangement. Let's see later. Now we want to calculate the gear ratio. Second, the next step is related with the gear ratio. We know that a driving gear is mounted on a motor shaft which turns at 1800 RPM. Okay, it means we have N1 as 1800 RPM. We have a N2 as 300 RPM because compressor shaft runs at 300 RPM. We know that we have a ratio. Okay, we can take it N1 by N2 or in reverse of RD2 by RD1. Anything is okay for us. Okay, so we have taken it 1800 divided by 300. So I have taken driving divided by driven. So for entire calculation, I will use the same formula. If it is in tooth, I will in connection with this, I will use it. Okay, so my 1800 is my driving and 300 is my driven one. So I got the reduction ratio. We got the speed ratio is going to be positive because we know that 800 RPM. It's basically a reduction ratio because 800 RPM means high speed. Whenever there is a high speed, we have a less PCD. Okay, what is the we have a driving gear runs at 1800 RPM and driven gear runs at 300 RPM. It means we are getting a speed reduction. Okay, okay, because my driving gear which runs at very high speed. Okay, so let us have a one example. This is pure mathematics. One equation we have RD1 plus RD2 equal to 21 point whatever 53 what is 53.3 centimeter or 21 inch. Second equation we have it RD2 is equal to 6 into RD1. Okay, we have two equations. Let us compute the pitch circle. We know we have a first equation RD1 plus RD2 is equal to 21 inch. We have a second equation RD2 is equal to 6 into RD1. Very effectively, you know this mathematics. Put it RD2 value in RD1. We will get the RD1 as a 3 inch. Okay, we know that RD1 plus RD2 is equal to 21. It means RD2 automatically 21 minus 3, we will get it 18 inch. This simple formula. We have just equated both these things. Okay, we calculated for radius, so double that, we will get the diameter. So my diameter of driving shaft is 6 inch and my diameter of driven shaft is 36. So that's why I have told you that 36 is larger diameter means we are getting speed reduction. Okay, speed is less at output shaft. Speed is less at output shaft means we are getting a speed reduction. So we know the gear, we have come across the PCD now. This is the most important thing. Okay, we know the gear ratio. Now we also know the PCD also. Okay, through this equation, and this is given in problem. I have not did anything from my own this, whatever the given in the problem, and this is the way you will get it. ऐसा नहीं होता कि whatever the application, whatever the inputs they have given, it is already there. You will get it minimum that inputs for you because your customer will tell you your machine has to run in between this RPM. I want this to be completed within 2 minutes, 3 minutes, whatever the time. So based on time, you need to decide what kind of an RPM you want. Okay. So now determine the number of teeth of each gear. So we know the gear ratio, we know the PCD. Okay. Now it comes to number of teeth. Okay, next step, and once we know the number of teeth, finish. We are done with the steps, whatever we are following now. So number of teeth, we know that we have a very handsome this N1 by N2 is equal to RD2 by RD1. Okay, anyway you can calculate with the either with the diameter or with the speed, you will get the same ratio. Okay, so the only one thing is remember the one thing is diameter. Okay, and number of teeth have a proportional relationship. I have told you diameter and number of teeth have proportional relationship. Means what? Speed and teeth are inversely proportional. Speed and diameter are inversely proportional. Speed and teeth are inversely proportional. मतलब दुश्मन का दुश्मन दुश्मन. So and those का those diameter and torque and diameter and teeth, they are on the same family. So diameter and number of teeth are proportional with each other. So DD2 on top side. So here also T2 at top side, DD1 at bottom side. So for teeth also T1 at bottom side. So this is a proportional way of diameter and tooth number of tooth. So here we got the things that with the help of this. We have already a speed ratio as 6. So from this, I have calculated T1 is equal to T2 by 6. We know that T2 is 72. Okay, already calculated. And this is the where I don't know. Now I need to assume X. You might be know that various application you need to assume something and reverse calculate. So here I'm assuming that let us assume the number of teeth as 72. You can assume anything. Okay, number of teeth as based on the diameter I will assume it. So I know that my diameter is okay. What are my diameters? I have a diameter of 18 and 3 inch. So for 18 inch and 3 inch, I am assuming that let us have on a over 18 inch we will have a 72 teeth. Okay, and over a 3 inch we'll have a 12 teeth. Okay, so half inch will be the tooth thickness between that. So let's see how we'll calculate. So based on this assumption, let us reverse the calculate. We have assumed something. Okay, number of teeth we have assumed it, and now we want to check it with the reverse way. So number of teeth in a spur. Okay, whatever the spur is the lowest small gear, and larger gear we called it as a gear. So we know this first checkpoint is n1 by n2 is equal to t2 by t1. The same way I'm getting the same uh, 1800 divided by 300 or 72 divided by 12. I'm getting the 6 as my gear ratio. Second thing is distance between the shaft. So we know that we have a RD1 plus RD2, okay, is equal to whatever I'm getting is 3 plus 18 is equal to 21. Because what happened 3 inch and 18 inch, it's again giving me a same. So but the here first thing, most important thing are both these PCD have a are in tangent. Okay, it means no clearance between the two PCD, and we must have a small amount of clearance between this. Okay, so for that purpose we need a small gap between the two PCD. So we'll require a clearance check for that. So for clearance check, we'll use the two dimension. We will either move slightly, we will move the driving part, okay, or we'll move the driven part during the installation. This is a very fraction of inches or fraction of mm. This is not something like that you will remove it from. This is just almost zero point 0.1 inch. It's also be larger, just a fraction of inch. You can have a clearance between the two PCD so that it will run. Okay, larger the clearance, it will slip. Okay, or larger the clearance, the two gears are separate, so only you will get the your driving gear will rotate, but driven will not. Okay, so there should be a small amount, fraction of inch clearance you have to provide it. Okay, and then based on that you need to select the catalog. Okay, based on that you have to be select the catalog. For first thing is PCD, so I think I have added the catalog here. I will just click and can't open the specific file. Okay, just give me a second. I will check with the few catalogs for you people so that you can understand the details. Just give me quickly. I can show it to you. That would be great for you people. Oh, this side. So I will get it the catalog here. No, I need to search it. The link has been disappeared, but I will have a few Excel that I will show it to you. Yeah. Okay. So here again, this is whatever I have did it. I need to calculate the linear speed and all. So you need to define the number of poles. This is related to the driving motor. This is the reduction ratio. I will type it. Based on that, I am getting the revolution. Based on this number of teeth, suppose I will take it. I have told you this is the manually we need to input. Okay, and then it will automatically calculate the diameter of these sprockets or whatever. This is for we are using a chain drive, but you can see this very handsomely. You need to just change the respective. I want a higher reduction ratio. So based on that, all the values are going to be get changed. All these color value are manually entered value, which are in this color are automatically calculated, and there should be some correction factor. Okay, this you can use as per the calculation. Okay, and all the formulas are and all these things are given, and you can able very handsomely you can able to get it. This is the another one which I used a lot more time. Okay, this is again for designing this sprocket kind of a thing where we need to mention the diameter. Okay, we need so what is the inner width of the roller? I will take it as a 40. Number of teeth is as a 24, and that's it. This is the way I will get it. All the PCDs and all those things. Because every time if I used to calculate this manual method, it is difficult. So that's why we have added this with a calculation sheet. I have that things ready with you, but I can't. Just give me a second again. I will try if I can get it immediately because I've just shifted a few of my data. Yeah, we got the Spur catalog. Yeah, this is the catalog. Yeah, handsome, great. This is what we wanted. So we know that we let us move for a. I don't know how that link has been lost. So we'll go to here. We have a what is the PCD 18 and 6. Okay. So 18 and we'll go to PCD first. Yeah, this is the one 18-inch and 3-inch. So come to catalog again. So go here about here is my 48 diametric pitch. I need to select for a 32, 24. You need to go with a specific one. Okay, from that we have a 18. Okay, we have you need to go for that specific calculation. 18 with the other dimensions are mentioned here, which is first one is pitch diameter, bore diameter, hub diameters if it is required. Hub means the external diameter. So I will do with this one of the selection with gear so that you people can able to understand this. So I'm just checking with whether I have a with the same diametric pitch. It means 2 pi r divided by number of thickness. If I can get it in this catalog, it's okay. Else, I will. We assume that this is the diametric pitch where I can able to get the both the gears. Okay, one is for 3-inch and another is for yeah. But these dimensions are in. I think it is in mm. Yeah, no, it is in inch. So we have 18. So select this 18 as a table. So if you select this 18, we have first pitch diameter. Okay, is for 18 we have 0.750. Okay, then what is the bore size we want it? Okay, what is the hub side? It means the hub is this external one. Okay, then what are the keyway sizes for it? Okay, what is the keyway size? They are given the number here, so you need to open again a keyway catalog for that, and inside a keyway catalog you will get the information related to it. So very all the details. Okay, first you need to select the category from where. Suppose here we have 18, so we need what is the pitch diameter for that, what is the bore size, it means where the key is going to be there, what is the keyway size. Here keyway size is we have a G131, and if you go to the specific catalog you can get it the key sizes over there also. We'll also check with we'll have any other catalog which is the direct connection to it. No. Okay, I don't want to go waste too much of an time into it. Okay, so we saw the number of steps where initially from problem definition to the clearance check. Okay, what the size we have to select. Okay, refer the catalog for a stock of the gear. Initially we have to select the stock of the gear from the catalog. We need to first select based on the PCD and number of teeth. We need to pick the available gear, and once you select the available gear, okay, and then you have to check with the manufacturer with that whether that available specific gear will what kind of and stress strength or what are the different ratios are associated with it, so that this could be performed for your application, and there should not be any kind of an failure in for a stress or deformation. So that's the way first selection will happen. Later we'll have a stress calculation, but in I think in a machine design, whatever you learn, it is directly the stress or strength calculation. And majority of the time, designer will not do any kind of a strength or stress calculation. Over the catalog itself, you are the direct, if your company is the direct vendor of that where the gear is manufactured, he will give you the another internal catalog where once you select that gear, it will calculate the, yeah, this particular gear will have a stress value up to this, and we have considered the yield strength up to this. This will be useful up to the deformation up to this. So all those things are mentioned on the catalog. Okay, so if you want to reverse calculate, we have another Excel kind of a thing that also I would like to showcase you, which is for basically for strengths, but it is huge, complicated one. So here you need to apply for a customer. It's almost, I will just make it some filter so that it will be easy for you people to at least understand the thing. Why I'm not getting filter here? Yeah, sort filter. I will just click all blank rows first. Okay, so these are the inputs. This is for all the every each and every tooth. Okay, you can imagine this is gullet means the one tooth. Okay, whatever the profile you have it, you need to type in all the dimensions of the end every profile. Okay, what is the tensile strength of your material? Once you type that things, you will get it the calculation part of it. It means first you will get it the all the calculation, then you need to get it the hub dimensions, you will get it the combinations, all those things. This is up to this, and finally there will be a calculation where you can get it the how much is the factor of safety. So this is huge. You can, I will just zoom it. This much is this, but this is for all types of gear. It means either you are using straight interspace. It means I'm talking about gullet. Okay, inside gullet is either a plain gullet or interspace. You can see this here. There are various nomenclatures are there, which is a plain gullet. Okay, that later we have a uh, interspace combination also. We have it a combination. We have a spline ended one. Okay, then we have a different brush type as then later is plain. So there are 4 or 5 type of gullet profile. We have it including the involute. Okay, serration is one. There are triangular profile you can get it. So based on, but this is for all. Okay, you might be required if you are selecting only involute type of gear. Maybe 30% of the calculation will goes from this. See, I have just open up the calculation table. Okay, else it will comes like 2 into 3, or if I have shown it this kind of an calculation, at least you can able to judge that, yeah, there is some formula. So in Excel we have a one facility where we can open up this C1 C2 else you can, if I use this, okay, you can't able to imagine that what is this. So this will looks like a C1 C2, and I need to go here and select what is the formula for this. But to ensure you should get the clarity, I have given this. Okay, you can see here how to calculate the PCD. Okay, they have calculated PCD is equal to module is d by t. Okay, so they based on that they called that Z BCD is my base circle diameter. So what I have did it based on that all the stock diameter, the lead pitch, and all those things. A lot of calculations are there. Okay, so based on that refer catalog, we used to select this one. First important thing is type of gear, center distance, gear ratio, PCD dimension, number of teeth. Okay, number of teeth is not directly, we can't get it directly. We have to assume any one of teeth, check it in a reverse way. Okay, we need to be checked because we have R1 plus R2 is equal to X distance we have considered. So if R1 plus R2 is X, then we will be in a trouble. So for that purpose, we require small amounts of clearance. So we need to check for the clearance. If clearance is not provided, gear will get locked. And then based on the available catalog, we have to check for a final gear size. And all the catalogs are already available. I think we have almost 10 minutes. I will just extend. but give you a very quick overview of gear train, because selection of only gear will not have a will not will not going to be sufficient as a mechanical engineer, but you must have a very good idea about the gear trend. Very fast, I will cover out these things, that whenever there are two or more gears are meshed with each other, we used to call it as a gear train. It means we have a two or more than two gears, we can call it as a gear train. So here we are using a number of gears, okay, in combinations with each other, so that we can get the multiple speed variation. For example, in a vehicle, we have a first gear, second gear, third gear, fourth gear, fifth gear. Okay, whatever the gears we have it. So what will happen? There are three, four gears are mounted on a same shaft, okay, or a multiple shaft, so that which one which you will going to engage, you will get the velocity ratio accordingly. So to get the multiple velocity ratio, okay, you will get it the respective gear train. So just a few seconds for this is the most important one is any gears which are going to get meshed with each other, their circular pitch or diametric pitch or module must be same. I already told you that your module must be same, and module or it is a diametric pitch which is always same. If module same, automatically diametric pitch will come, because it is a it is a diametric pitch or circular pitch is a piece 2 pi r pi d divided by t, so it automatically comes equal to module. We have a second thing is idler gear. Idler gear is only used to change the rotation, so that if for external gear, if driving rotates in a clockwise direction, definitely driven rotates in the anti-clockwise direction. But the case is where we also want our driven to be rotate on the same direction, so we will use an intermediate gear where there is no any kind of an purpose for this. The only purpose is to change the direction. Okay, so that driving and driven here will be rotate on the same direction. Very interesting one. I will just compute few things here. We have four types of gear train. I will morely focus. I will just explain quickly these things and few problems within 10 minutes. I'm sure that this is not sufficient time, but this will I will 100% know this. You people will easily understand this topic. First gear. Okay, here you can see this. Okay, this we have a reddish color, blue color, and green color. Okay, I'm highlighting. I will highlight this to spotlight. Okay, just concentrate on this link. We have a three colors here. On each shaft, we have a each gear. It means on this this reddish color gear is on a red shaft, blue color gear on a blue shaft, green color gear on a green shaft. So every shaft carries only one gear. Each shaft carries one gear. That's called it as a simple gear train. Okay, this is the same case whatever we have did it just few seconds before. Okay, the same case where each shaft carries only one gear, so velocity ratio between these two shafts remains same, and this in between gear, it is called it as idler gear, will only be useful to change the direction or to compensate the length. Okay, both we can't take the larger diameter gear, so to compensate the length is in between limbu timbu, we will take it in between, so that we can change the direction also, and we can have a we can compensate the length, so that smaller gear can accommodate the things, but only one gear on one shaft. The same way here we have a compound gear train. It means if your shaft carries more than one gear, if your shaft carries more than one gear on a single shaft, that is called it as a compound gear train. It means here reddish color, second image, reddish color. Okay, here red color, one shaft, one gear, but a middle gear, we have a two gears. Imagine we for here we have a yellow and blue. It means this yellow gear and blue gear mounted on the same shaft, so that is more than one gear is connected to the each shaft, so we'll get the multiple speed variation. Okay, it is idler, but still it is it is giving me a speed variation, so that's why it is called it as a compound gear train. Reverted gear train is something like you can see here, your input shaft axis and the output shaft axis are collinear. Very simple, means जहां से इनपुट शाफ्ट है, ओके, फॉर एग्जांपल इन रामायण क्या होता है कि रावण म्हणजे रावण आणि राम एका साइडने ते बाण मारतात, सो दे आर विल डॅश विथ each other, so mean they both are collinear with each other. Okay, so both are collide, these two arrows are collide with each other, so that is kind of a thing is called it as a reverted gear train, where your input shaft as well as the output shaft remains on the same line. Okay, so either say and on the both the sides. So that is called it as a reverted. Epicyclic is something like which is the inside. Okay, planetary. Okay, and direction remains same. Okay, and but it have a multiple axis. Okay, you can get it on over a multiple axis, and once it is a multiple axis, there is a lot of calculations of theta, r theta, and all those things with the epicyclic. I will not go in a detail of epicyclic. Even I have not used too much about the epicyclic calculations. Okay, uh, but definitely these three things. I would like to brief you about this. I have already told one shaft is on each shaft carries only single gear. Okay, when the distance between shaft is very small, okay, and we want to transmit the power. This is the case. Okay, this is the A diagram. Okay, one driver, one driven. Okay, here we have in between idler gear. Here we have a two gear. So it means that first gear rotates in a clockwise direction, second one in anti-clockwise direction, third one again in clockwise direction, fourth one, okay, reverse of that clockwise. So this way, this will get fluctuate, okay, and we will get it into it. Very important thing, speed ratio and train value. Okay, this is the I think major. There are few question paper. This question is asked. What is the difference between the speed ratio and train value? Speed ratio directly we have discussed a lot of time. Inverse of speed ratio is train value. Okay, very simple. Inverse of speed ratio is called it as a train value, and many times this calculation will comes into the picture where they will ask you to calculate the train. Even a few gate exam, this question is, or even a few IAS exams also, they have asked about the train value. Okay, so inverse of speed ratio is train value. All other things are same. Let's have a few things. Whenever there is a distance is large, I have told there we are using some intermediate gears. That intermediate gears is called it as idler gear. Okay, that intermediate gears is called as idler gear. And whenever there is a one gear on one shaft, okay, we need to be check the engagement. It means one and two. Okay, so driving, which one is driving? Suppose one. Which one is driven? We have a two is the driven. Okay, and then suppose for the next sphere we have a 2 and 3. So 2 rotates, that's why 3 rotates. So we need to equate the 2 and 3, and all the formulas are related with the same. It means for 1 and 2 we have n1 by n2 equal to t2 by t1, but for 2 and 3 we have a 2 as a driving, so n2 by n3 is equal to t2 by t3 by t2, so because it's a reverse. So we only, because we are considering only one gear on one shaft, but simultaneously if you equate these two equations, okay, we will get it that this n2 and t2 becomes get deleted. Now n1 and n3 equal to t3 by t1. So this is the one. I will tell you in a very simple way. Compound gate, and I have one example. Very interestingly, I have told you that whenever there is a multiple gears on the same shaft. If you, I want to explain this for 5 minutes, and I will take a break on it because I'm sure that this will be the very handsomely written. So here we have a gear 1 on shaft A. Okay, here we have a gear 2 and 3 on shaft B. Understood? Okay, A, B, C, D is the shaft. 1, 2, 3, 4 are the gears. Okay, simple. So we have a gear 1 on A shaft. We have a B shaft whose have a 2 gears, 2 and 3. We have a 4 and 5 gears on a shaft C. Okay, and last one is my final shaft, which is the output shaft. We call it as a driven shaft, which is again we have only single shaft. So power from A shaft to D shaft. Okay, power or torque we want to transfer from A shaft to the D shaft. So how we transfer the power between this? We know that. Just draw this schematic. If you draw this schematic, I'm sure that everything, all the questions, problems related with the gear ratio will get solved. 1 drives 2, correct? Next, 3 drives 4, okay, because 2 is not connected to anyone. Okay, so 3 drives 4, 2 and 3 on the same shaft. Here, correct. Second gear and third gear on the same shaft. Agree. Next one, we have a fourth gear which is C and fifth gears on the same shaft. Here, one is on shaft A, two is on shaft 2 and 3 is on shaft B, 5 and 4 on shaft C, and 6 is my shaft D. Same way, this is the diagram I have drawn like this. Now we want to calculate the speed ratio. Okay, this is the most important thing. So whenever you take speed n1 on top, we know that we require n2 at in this slide. So to calculate this, many people will struggle for this. I will give you a very handsome answer for this, and I'm sure from today you will not forget. You know that here you require for speed, I want n1 is my driving and n6 is my driven. This much is very easily understood for every problem, because we know the input shaft, we know the output shaft. My input shaft is n1, my output shaft is n6. I think this is clear to everyone. Now we have created this diagram. Okay, let us see this one. All arrowhead means what? 2, 4, 6 is on top side. All are driven. Divided by all arrow tail means 1, 3, 5. Okay, it means what I have did, all arrowheads means what? Power is transmitted from 1 to 2. Arrowhead comes to 2. Here arrowhead comes to 4. Here arrowhead comes to 6. Got it? Then who are the driver? Where is the tail? First start with 1. Here is 1. Okay. Then we have a 3. Here is the tail. We have a 5. Okay. One have an arrow, have a head and tail. So I have defined this arrowhead divided by arrow tail. Simple. So now let's see how to calculate in book. Okay, book method I will show it to you. Okay, this I have mentioned that arrowhead means 2, 4, 6. Arrow tail means remaining. This is the book method. Drive all those things, calculate, and these are these cut hota hai, and all those things, and finally you will get the same one which I have told you, 2, 4, 6, 1, 3, 5. Which one is easiest one? Arrowhead divided by arrow tail. But you need to calculate the freehand diagram based on this. And if you know how to calculate the freehand diagram, then this is the problem. Okay, we have A which runs at 20, B and C, okay, are on the same shaft. So B have a number of teeth 50, C have a number of teeth 25, D have a teeth 75, E have a teeth 26, F has a teeth 65. So it is very easy. A is my driving, F is my driven. Okay, A is my driving, F is my driven. Let us calculate one diagram accordingly. Okay, and this will end for this. So we have a NA, and the problem also given with the some inputs. This is A rotates at 975 rpm. Okay, a gear make a machine tool, a motor shaft is running at 975 rpm. A gear wheel B, C, D, E are fixed to the parallel shaft, rotating together, and F is my fixed output shaft. Okay, it's the larger one, 65. And what is the speed at F? So I'm running a shaft with 975 rpm, and I want to calculate the rpm at this end. And this is the favorite question many interviewers ask. So we know that A drives B. Just closely watch where the tangency or engagement happen with PCD. A and B. Here C and D. Here E and F. Hope you people can able to see the spotlight. A and B, C and D, E and F. Understood? Okay, this is more important. I will again change spotlight to my normal so that I can zoom out. Okay, hope you can see this. A to B, next B, then B and C on the same shaft, so C to D. Okay, then E to F, that is finished. E and D on the same shaft. This is the diagram I have to take it. Now my calculation what suggests? I know that my speed of the driving is 975 divided by, we want to calculate the speed of the driven, then my best formula, arrowhead divided by arrow tail. So we'll select what are the arrowheads? B, okay, D, F. Okay, let's see, B, D, F divided by A, C, E, arrow tail. Let's see. BDF divided by A C E. What is B? B means TB, D means TD, F means TF, A means TA, C means TC, E means TE. All values are given. Just put it and calculate. We know NA and NF. NA we know, and NF we have to calculate, and this TB, TD, TF, all these are already given in a problem. That's it. Finish. Once we calculate the Na by Nf ratio is 18.75. Okay, we know that Na is 975. So 975 divided by 18.75 is equal to Nf is the speed, which is 52 rpm. So very interestingly and basically, but this required this way I understood the gear train. So I thought that because what happened, the book method is very cryptic, and every time you people will struggle with the calculation part of it, and but this way, and this is 100% required. This is the most important chapter whatever I'm taking to you, and this way various compound gear train calculations, and majority of the time compound gear train is the most difficult calculation. All other calculations are simple, but compound gear train require very high amount of concentration, and anything you miss it on the top side or bottom side of number of teeth, you will be suffer a lot. Okay, so I don't want to take it reverted gear train. I have already told you the axis is coaxial. I don't want to take a problem with about this, because we do not have a time to. I don't want to extend the too much time, but definitely if time permits, I also have a few handsome things to tell to you people, and definitely it is useful for a long run. So I think it's, how much is the time? It's 7:10. Sorry for extension of 10 minutes, but definitely I know that this is the fastest session I have taken it on a year. Might be my speed of talking is little bit higher. I have skipped it out a few things, but I thought that just have a justice to the each and every topic, and if if you have any queries or doubts, tomorrow also I know that there are a lot of doubt on here. Tomorrow also I will take it a session on this, and if you have any mentioned doubts, okay, you can type it on a question answer session, so that I can able to answer those queries to each of them. How much minimum teeth can be manufactured? This minimum teeth manufactured is depend upon the application. You might be see the teeth on your watches. Okay, very small dimension teeth. Even there are some nano material. Okay, nano is coming. So you know that over there also be a very small and minimum teeth size is there. So we can't. It's depend upon the application, Mr. Santosh, and depend upon the application, the number of teeth is going to get vary. Okay, because application changes, nanomaterial have very small teeth. Great, you are Marathi. I thought you. No, no. I'm a pure Maharashtrian. I stay in Latur. My name is looks like Atmaling is basically named from. It looks like from south side, but I'm a pure Maharashtrian. I'm born and brought up with my father in Marathwada, Latur area. So if you we don't get the any catalog, then yeah, if you do not get any catalog, please call me. I have enough catalog of gear. You can get it which one you want it, no problem. How to select the tolerance of gear design? Yeah, tolerance selection of gear design. Dear, it is a huge chapter. I cannot cover it into this, because for tolerance selection for the gear is in micron. Okay, and because it's again depend upon which broach you are going to use to manufacture that particular thing, but depend upon the application. I suggest you, if you are a gear design person, then and then only people will think about the gear tolerance. Okay, else the tolerance will be accommodated on key. Okay, and backlash, all other things which where your gear should not get slip. That is the most important criteria. Gear design tolerance, as a machine designer or as a designer, you don't have to worry about it unless and until you are purely from gear background, or your company manufactures gears. Definitely it's huge hectic to you, because I shown you a few tables. You can't imagine the calculation of gear. The most difficult calculation of any engineering is gear calculation. Okay, and have a huge kind of things into it. It's difficult to cover. Can you share me the Excel sheet? I can it, but definitely if I share the Excel, I can share a lot of formulas are available. I thought that you think on it, because initially first day there were a lot of challenge. A lot of people are asking about the day one recording, but when I saw the number of viewers, I saw a little bit less on it. So first, whatever you understood it, please note it down. Okay, any queries you can. I already have mentioned my mobile number over there. You can call me. Definitely, I would like to answer. And for gear, I have worked with Motherson, Sumi for almost 2 3 years, and I can give you the even from involute calculation. Okay, all those details I can able to give it to you. What does you mean by a planetary system? Planetary system is basically all the gears are inside of a circle. Okay, it means you have one sun gear, a larger gear, and a larger gear have an axis. Okay, and over that axis we have another two, three, four smaller gears, depend upon the application, and the power is going to be transmitted to the one gear to the other gear, but their axis is different. That is called it as a planetary gear. Okay, it is. I know that I'm very theoretically clear with the gear system because of a lot of work into it. But planetary gear system is used for an internal kind of a gear train. Okay, it's again a gear train, but it is used for a multiple axis, and whatever the gear ratio you will get it from inside itself. It is used mainly when there is very less space is available at that time. It is to be used. Have you designed carbon fiber gear? No, dear. I not designed any carbon fiber gear. Carbon fiber gears. I used to be work on all the applications like stainless steels or ductile metal applications. Okay, now, not but which is hardened and toughened one, so that it can be accommodate the normal application. But HSS I use it, but not the fiber you want it. How to select the material for gear? Yeah, Omkar, I think there are a lot of criteria based on this, whether your gear is working on which condition, what is the vibrations are caused, whether you are working with the corrosive environment. Okay, so that also be important criteria. Then again, basically environment. Okay, whether you are going to work on inside under the water, so there is some criteria for that. So based on the application criteria and the environment, the gear material is going selected. Next part of it is the whatever the alternative gears. Okay, where you shaft and your availability of the shaft of the motor and driving. This also be going to get checked. The reason behind this is because gear is keyed to the shaft of the motor. Okay, with the help of key, so it should not get wear and tear and all those things. So a lot of criteria are there. Then how efficient our gears are. Most efficient is gear. I suggest you, because you imagine the landing gear of even a aeroplane. Okay, even your all the I called it as engine. Okay, where gearbox and all those, where majority of the time where you require a precise control, you go with the gear, because there is no any another element into it. For a belt or chain, it may chance that your sprocket or your chain itself, the linkage is going to get break. But gear is considered to be a more efficient way. There is no any other another medium is engaged. Okay, whatever the power or torque is transmitted through the successive engagement of the teeth. Okay, that creates an additional advantage, and you can get the advantage of it. So for motion animation of gear in SolidWorks MBD, can we use only PCD for constraint to motion? Not required here. Even no need to no need for having a motion of gear in SolidWorks. MBD leave it, but for SolidWorks, you need to only give the surface. Okay, no need to even draw the entire geometry which looks like a gear. You can only have a simple disc, two disc. Okay, having the whatever the PCD you wanted, no gear profile on it, and you can define a gear mate for that, and you can able to get the respective gear ratio as per the diameter available. Sir, can you explain about the involute and epicycloid on a gear teeth? Uh, Involute, epicyclide, I have not worked too much of it, but involute, yes. Basically, you have a string. म्हणजे for example, काय म्हणू शकतो मी, तुम्ही एक दोरा घेतला, दोऱ्यामध्ये दोऱ्याला जेव्हा तुम्ही एक काहीतरी स्टोन असेल तो त्या एंडला बांधला आणि when you try to rotating over your head, जोरात 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 फिरवल्यानंतर तुम्ही तो दोरा सोडला, जो काही ट्रॅव्हल कॅरी होतो, दॅट ट्रॅव्हल इज कॉल्ड इट ॲज इन्व्हल्यूट. आणि तो जो इन्व्हल्यूट ट्रॅव्हल असतो ना, इट इज कॅल्क्युलेटेड बेस्ड ऑन अ सर्टन फॉर्म्युलेज. ओके, सो दिस इज बेस्ड ऑन एक्स अँड वाय. Okay, so x square plus y square. There is a one formula related with the involute profile. Details are there are a lot of things into calculation of the involute. It is called it as a. It might be you will not understood it. It's called it as a GH value. Okay, GH and I value. Okay, GH and I value defines the center of the that arc of the involute profile. Again, this involute is carried on a multiple points. It means over that DHI you will get it the hundreds of point, and from that hundreds of point, whatever are the close points, they will meet one by one, one by one, and then whatever the profile you get it, it is called involute. It is difficult to explain it, but maybe tomorrow you please join Vishal in morning session. I will definitely show you how to create the involute based on the Excel sheet. I have it where I will just give the input to the Excel, and it will generate the involute profile inside the Excel itself. Very handsome tool, I have it. So that I can show it to you tomorrow. Today it is very difficult and time consuming. Gearing system can we use in EV? Yeah, you can use it, no problem. Uh, when we design a gear, it is essential to check the material. Yes, it is. It is. Material is the important criteria, okay, for any mechanical engineer, because your right type of material for right application is the key for the success. Then how efficient our gears are? I have answered this. Uh, I think there are a lot of questions. I request please join tomorrow's session, because it's almost people are also living from here, and it's almost we have crossed the 20 minutes. But still, if there any important question, I will take it. Sir, selection criteria for gear in industry. I have told Omkar, but if you need more help, you can connect tomorrow. I will explain you, because that's the reason we have a separate question answer session, so that you can think at late evening today and come up tomorrow with a question. I'm happy. Whatever things I know it, I will share it to you very frankly. If I don't know, I will tell you that I need a I need to study, or I will ask someone to answer your question. But you will definitely get the answer from our side. When we design gear, it is essential to check the material we have taken. If any question is remaining, please post it again, or join tomorrow's meeting. The way you give the tips is, yeah. Okay, I think I would like to take a break for the today's session. I think we have very interesting topic for tomorrow. I know that tomorrow is Sunday, but still now everyone is on lockdown. So join tomorrow for SOLIDWORKS parametric design for teacher. If you miss tomorrow's session, it will be difficult for you people to understand the other sessions. So let's join tomorrow for SOLIDWORKS again. Okay, so we'll enjoy the rest of the evening. Thank you very much. Thanks a lot.